All right, this will be a much quicker video where I go over an integral that can be evaluated by u sub after a clever substitution. Okay, so let's look at 17. All right, and we always let u be what's under the radical, right, or inside the parentheses. And again, and your initial look at this, right, might make you say, I don't think I can use u sub here. I don't see, when I take the derivative, right, I see x cubed. I don't see just an x, right? But again, with clever substitution, we can manipulate this statement of what we let u equal to solve it for x and be able to cancel out the x that remains as part of our integrand. All right, so let's start with 17. Again, the first thing students try to do wrong is they try to distribute, right? Why can we not distribute? All right, and I hope we're getting good at this, right? This 10 is why we can't distribute, because order of operations, PEMDAS says exponents before multiplication. All right, but notice what happens. I let u equal x minus 1. All right, du dx, that's just 1, right? The derivative of x minus 1 is just 1, which means that if I multiply both sides by dx, right, du is simply equal to dx. All right, so let's go back and substitute everything for its equal. So again, I might feel like I can't do this problem, right? Because I'm going to have this extra x here. Then I'm going to have u to the 10th. And then I can just replace dx with du. They're equal. All right. Common mistake, right? Common mistake. Students say, oh, I'll just pull the x in front, right? Because I can't have both an x and a u, right? So I'll put the x in front. Very common mistake. However, the issue is x is not a constant. Let's see, can I fit this in here? Not a constant, right? Only constants can get moved in front. All right, so x is not a constant, can't go in front. All right, but what I can do is I can go back to the statement where I define u. All right, I have defined u in terms of x, and I can do some manipulation on this statement and notice that if I added 1 to the opposite side, x could be written as u plus 1. That's where I'm allowed to then replace x with its equal, right, in terms of u, because I can't have both x's and u's in the same integral, right? I have to be either all x or all u. And it's interesting the way this works, because the last time, that sort of looks like a v, but it's a u. The last time, when we wanted to distribute, right, a lot of people would try to distribute here x into the parentheses to the 10th power. Notice I flip-flopped where u is to the 10th power, a single term is to the 10th power, and what's in parentheses has no exponent, right? That is what enables me to now distribute. Okay, so see how flip-flopping that, right? That the u minus 1 became just the single term to the 10th, but then the x became the binomial, right? Now I am able to distribute, and at this point it should become a nice, easy problem. All right, so I'm going to distribute and get x to the, or u, I'm sorry, u to the 11th plus u to the 10th du, u to the 10th, sorry, those look like v's, they're supposed to be u's. U to the 11th plus u to the 10th du, and I'm going to leave it for u at this point to solve.